Hi, I am T. Kavitha, Assistant Professor, Department of Mathematics, Dr. S.N.S. Rajalakshmi College of Arts and Science. Today's topic is assignment problem. The assignment problem in operations research is a classical optimization problem. It involves assigning tasks to agents like jobs to workers, machine to tasks, etc. in a way that minimizes total cost or maximizes total profit with a constraint that each agent is assigned to exactly one task and vice versa. It is a special case of the linear programming and transportation problem. This problem can be solved using the Hungarian algorithm. The Hungarian method is a simple way to solve assignment problems. Let us first discuss the assignment problems before moving on the learning the Hungarian method. What is an assignment problem? A transportation problem is a type of assignment problem. The goal is to allocate an equal amount of resources to the same number of activities. As the result, the overall cost of allocation is minimized or the total profit is maximized. Because available resources such as workers, machines and other resources have varying degrees of efficiency for executing different activities, and hence the cost of profit or loss of conducting such activities varies. Assume we have n jobs to do on m machines, that is one job to one machine. Our goal is to assign jobs to machines for the least amount of money possible or maximum profit, based on the notion that each machine can accomplish each task but a variable levels of efficiency. The next one is the steps for the Hungarian method. Check to see if the number of rows and columns are equal. If they are, the assignment problem is considered to be balanced. Then go to step 1. If it is not balanced, it should be balanced before the algorithm is applied. First step. In the given cost matrix, subtract the least cost element of each row from all the entries in that row. Make sure that each row has at least one zero. Again, I repeat, in the given matrix, subtract the least element of each row from all the entries in that row. Make sure that each row has at least one zero. Step 2, correspondingly we take the column reduction matrix. The step 2 is, in the resultant cost matrix produced in step 1, subtract the least cost element in each column from all the components in that column, ensuring that each column contains at least one zero. Step 3, assign zeros. Analyze the rows one by one until you find a row with precisely one unmarked zero. Encircle this lonely unmarked zero and assign it a task. All other zeros in the columns of this circular zero should be crossed out because they will not be used in any future assignments. Continue in this manner until you have gone through all the rows. Examine the columns one by one until you find one with precisely one unmarked zero. Encircle this single unmarked zero and cross any other zero on its row to make an assignment to it. Continue until you have gone through all of the columns. The next step is Step 4. Perform the optimal test. The present assignment is optimal if each row and column has exactly one encircled zero. The present assignment is not optimal if at least one row or column is missing on assignment. That is, if at least one row or column is missing one encircled zero, continue to step 5. Subtract the least cost element from all the entries in each column of the final cost matrix created in step 1 and ensure that each column has at least one zero. What is the step 5? Step 5 is draw the least number of straight lines to cover all the zeros as follows. First one, highlight the rows that aren't assigned. Second, label the columns with zeros in marked rows if they haven't already been marked. Third step is highlight the rows that have assignments in indicated columns if they haven't previously been marked. Next step, continue with B and C until no further making is needed. Simply draw the lines through all rows and columns that are not marked. If the number of these lines equals the order of the matrix, then the solution is optimal. Otherwise, it is not. Okay. Step 6. Find the lowest factor that is not covered by the straight lines. Subtract these least cost component from all the uncovered elements and add it to all the elements that are at the intersection of these straight lines, but leave the rest of these elements alone. Step 7. Continue with steps 1 to 6 until you have found the highest suitable assignment. Next we go on to the one example problem, that is Hungarian method assignment problem. The problem is, use the Hungarian method to solve the given assignment problem stated in the table. The entries in the matrix represent each man's processing time in hours. Here mans and hours are given 1 2 3 4 5 1 2 3 4 5. Okay, 20 15, first row is 20 15 18 20 25, the second row is 18 20 12 14 15, third row is 21 23 25 27 25 17 18 21 23 20 18 18 16 19 20. Okay, here the solution with 5 jobs and 5 men are given. Therefore the given problem is balanced. We take the matrix as A is equal to 20 15 20 18 20. Okay, first we have to simplify the row reduction matrix. Okay, first row minimum is 15, second row minimum is 12, third row minimum is 21, fourth row minimum is 17, fifth row minimum is 16. We subtract these minimum elements in the corresponding rows. So we can get the row reduction matrix. Subtract the lowest column element in each row from all the elements in the given cost matrix is row. Make sure that each row has at least, this is the first step. Okay, now we get the row reduction matrix 5 0 3 5 10. Second row is 6 8 0 2 3. Third row is 0 2 4 6 4. Fourth row is 0 1 4 6 3. Last row is 2 2 0 3 4. In this matrix, next we convert it the column matrix. The column matrix, first column smallest element is 0, the second column smallest element is also 0, third column is also 0, fourth column the smallest element is 2, so we can subtract this 2 in the fourth column. Fifth column smallest element is 3, therefore we can subtract the fifth column. Okay, now the row reduction matrix 5 6 0 0 2, the first column, second column 0 8 2 1 2, third column 3 0 4 4 0, fourth column 3 0 4 4 1, fifth column 7 0 1 0 1. The next step is drawing the minimum number of lines covering all zeros. The optimum assignment, the single first row has only 1 0, so we encircle the first 0. Second row it has 3 zeros, so we can wait. Third row only 1 0 in first column, we encircle this. and at the same time fourth row is also 2 zeros, so we can wait. The second last row we have only 1 0, so encircle it. Now we encircle the only first row 0, third row 0, fifth row 0. Next we take the column wise. First column already third element is selected, therefore we cross the fourth 0, fourth row first 0. Okay, then automatically we select the fourth row fifth element, fifth 0 is selected. Now if we select fourth row fifth element is selected, then automatically second row fifth 0 is cancelled. Therefore the second row fourth element is 0 is single, therefore we can select the 0. Now we get the optimal assignment in every row and column. Okay, therefore the optimum assignment is, the present assignment is optimal because each row and column contain precisely one encircled 0, where 1 to 2, 2 to 4, 3 to 1, 4 to 5 and 5 to 3 are the best assignments. Hence this is equal to 15 plus 14 plus 21 plus 20 plus 16 is equal to 86 hours is the optimal time. This is the optimal time for this given problem. Okay, thank you.